everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. So in this video, I'm going to discuss about the overview on data management and representation. So the main objectives of this subject means with the students can able to understand what the term data and then what are the various types of data and various methods of data available for data collecting, and then the students can also be understood what is the difference between the means and interpretation of the data. So that should be presented through tables, graphs, and then charts, right? So at the end of this video, the student can able to learn all these things. So very first that data. So what is the data? So data is nothing but a collection of facts such as values or measurements, and it can be in the form of numbers, or it may be in the form of words, or it may be in the form of measurements or observations, or even just description of the things. And simply the data is information here, right? So the data is nothing but a collection of facts that may be in the form of values, or it may be in the form of measurements. So this data can be expressed in the form of numbers, or can able to be in the form of words, measurements, observations, and even just the description of the things. So the data types will be of different things like numerical data and then categorical data. Again, this quantitative data and categorical data will be treated as the qualitative data. So this numerical data will be of two types, like discrete and then continuous one. So the data should be numerical data and categorical data. So the numerical means quantitative data and categorical means qualitative data. So again, this numerical data will be discrete one and then continuous one. So these are some of the various forms of the data where you can able to represent it. So it may be represented in the form of numbers, or it may be in the form of categorical values. If I consider this numerical one, then it should be again discrete one, and it may be continuous one. So what should be the qualitative data and quantitative data? So the data what I described, you have to be familiar with this, whether it is a qualitative or it may be a quantitative. So qualitative means it should be in the form of descriptive information. So it should be describe something, whereas quantitative means it should be in the form of numerical information, that may be in the form of numbers, right? So the data what is getting from various sources like primary and secondary, right? So we have to be identified whether it may be a qualitative or it may be a quantitative. Similarly, the data what is getting should be qualitative, or the data what is getting should be quantitative. So like this, we have to be very familiar. The data what is getting should be qualitative or quantitative from the various sources. So the qualitative means descriptive information is going to be there, and which means this is nothing but describe something. And quantitative means numerical information should be there, like weight in kgs, height in centimeters, like this. Some specification should be there for the variables, or some unit should be there for the variables. So numbers, okay, like this. So let me explain clearly about what the difference between the qualitative and then quantitative. So quantitative and qualitative, right? So the qualitative means it should be able to deal with the descriptions, whereas quantitative deals with numbers. And the data can be observed but measured, but the data which can be measured here, right? So the data what I getting can be observed but measured, but here the data which can be measured. So examples this of qualitative data will be colors, So it may be red color, blue, green. So is there any units for this? No units. So it should be qualitative. So textures, smells, tastes, appearance, beauty. So these are the examples of qualitative. So qualitative means quality. Simply, what can I say? If I took this quantitative, so the quantitative deal with numbers which can be measured one, and like example should be length in centimeters. Sorry, yeah, meters and centimeters. Height should also be expressed in terms of centimeters. Area, weights in kgs, temperature, centigrade or Fahrenheit, speed, kilometers per hour, time in seconds, ages, 22 years, numbers. So what is this variable? What I took, if I have this units like this, then it should be considered as quantitative data. So quantitative data is nothing but the quantity. So qualitative is nothing but quality. The quantitative is nothing but quality. The quantitative data again should be of a discrete one or it may be of continuous one. Okay. So discrete data can only take certain values like whole numbers, and continuous data can take any value within the range. So discrete data 10, 20, 30. Continuous data, if I took some 4 p.m. to 5 p.m., in between the range, the data what is appearing, let it be time, then it should be treated as the continuous data. Discrete data will be counted, but the continuous data is going to be measured. This is the main difference between this discrete and continuous. So the discrete data is going to be counted, whereas the continuous data is going to be measured. So example, if I took, so we know this already from the picture, it is this tiger. So the data what I get from this picture, right? So the tiger is brown and then black, and it has a long heads and it has a lot of energy. So brown and black, is there any convention for notation for this? No. Long heads? No. And lot of energy? No. Right? So the data should come under the qualitative, right? By seeing the pictures, we can extract some of the data. So, but the data all should come under the qualitative only. So, if I took a quantitative data, suppose the tiger has 4 legs, so that is the numerical data, and it has some 2 brothers like this, then it should be again quantitative. And then continuous, again it may be discrete or continuous. So discrete should be this, and continuous should be weights. So weights 400 pounds. That should also have convention. And similarly, feet 3.5 feet tall. So it should be again numerical value, but it should be either it is a discrete one or it may be a continuous one. We have to be identified. So explain some other types of data also available, like so which is normally presented on the maps and planes and provides an indication of where things are. So that should be the spatial data. And definitive data means usually provide in the form of drawings which define a particular item and the way in which it has been or to be built. It should be definite data. So the spatial data normally presented on the maps and the planes and provides an indication where the things are. That should be spatial data. And definite data means it should be provided in the form of drawings or which enable to define the particular item and the way in which it has been to be built. That should be definite data. Available for the data collection will be abstractive methods and unobstructive methods. So abstractive data collection methods can be directly obtained from the information from those it has been evaluated, like interviews, surveys, focus groups, and observation, case studies, questionnaire. Okay, so the data, this and all will be considered as the abstractive data collection. Abstractive means we are unable to abstract the data directly from the information that is going to be evaluated by conducting interviews, surveys, focus groups, observations, case study, and questionnaires. And unobstructive data means the data what we collected is the information directly from the evaluees. So like document analysis, observation at a distance, right? So this should be unobstructive data. So data collection tools, what are the data collection tools? What we have here is participatory methods and then records and secondary data, observation and surveys and interviews, focus groups, diaries, journals, self-reported checklists, like so the data collection tools will be primary methods and then which will also records and then secondary data and observation, surveys and interviews, focus groups, diaries, journals and self-reported checklists. So these are the some of the methods that are available for the data collection tools. So continuation of that. So we also done some of the methods like expert judgment and then Delphi techniques and other tools like scales, tape measures, stopwatches, chemical tests, and quality of measures should also be one of the other kinds of tools that are available to gather the data. And health testing tools like BP pressure, and then citizen report cards like this. So these are some of the tools that are available for collecting the data. And for the data presentations, what we have, suppose we already collect the data, then what we are going to represent the data. So for that, what we're having here is tables, graphs, and then charts, right? So data presentation, so the data is collected and we have the methods and then how we're going to represent it. So one of the thing is the tables. So whatever the data we collected, I can able to represent in the form of rows and columns. We have to be follow some of the rules and regulations of this, uh, like we should be considered the name of that table and then sizes, everything should be clear that. And graph, if I'm going to take, so where can I able to represent different types of graphs, uh, like line graph, and the charts, if I took like pie chart, bar chart. So like this, some of this can able to represent the data what I collected in the form of tables or line graphs or pie charts and bar chart. Again, we should be a bar chart will be of different type, and pie chart should also be different type like this. So these are some of the ways of present. So tables, if I took, so the simple way to summarize the data should be the table, and data is going to be presented as absolute numbers or percentages. So the data what I presented should be represented in the form of absolute numbers or in the form of percentages. So example, suppose an adults and children with HIV and AIDS by reaching the country X, Y, and the end of the year X, I want to find it out. So the data I'm getting, but I have to represent the form of table I want. So I can able to take it as regions, and adults and who is greater than 15 years I'm taking, and the children's less than 15 years I'm taking, and then how many number of people are affected, and total I'm taking here. So if I take the region 1 here, so I can number of adults greater than 15 years should be 14,800 people are available. And similarly, if I took the children, so uh, totally I have less than 15 years, I have 200. The sum of this will be 15,000. So similarly, if I take another region here, and so number of adults should be greater than 15 years should be 4 lakhs, and it should be 20,000, and the sum should be this. So charts and graphs here. So charts and graphs, so normally going to be used for the visual representation of the data, and the data what I presented should be presented as the absolute numbers or in the form of percentages, right? So the graphs are mainly used for the visualization, and the data what I presented is to be taken as an absolute number, or it may be a percentage. So you have graphs like, so the graphs are mainly used for making the data easier to understand. So even the uneducated people can also be clearly understood by seeing the graphs what it is. So below is the table without the data, and worldwide disease ratio I'm calculating. So if I'm going to represent this data in the form of tables like animals, so if I take AIDS and something, what are the cancers I'm getting and what is the quantity of that one, I'm representing the form of a table. Okay, but if I'm going to be represent the form of graph, how it will be? So by taking this animals on x-axis here and y-axis here. So by taking this, so if I represent, so what should be its percentage? It should be 65 around. So that's why I'm taking it as a 65. So similarly, cervical cancer, it should be around 28, and diabetes 70, and lung cancer is 33. So 70 and market and then 30. So by seeing this graph, so what we can able to understand. So even an uneducated person can easily understood. So the more number of diseases are going to be affected through the diabetes mellitus. So by seeing the graph, we can able to clearly understand. By seeing this table, we can able to analyze the table. But by viewing this graph, so what the people or uneducated persons can easily understood what is this meant for. So who are the people less affected? There should be cervical cancer like this. So that is the advantage of this visual presentation of data through graphs. Similarly, I have bar graph like lung cancer, and if I took this, how much percentage of this remaining one, and similarly diabetes, cervical, AIDS, HIV like this. So by this should be one other type of the graph. So previously this is the vertical one, and this should be the horizontal one. So the graph should be of different types, horizontal, vertical like this. So similarly, I can able to some other graphs also and have like composite bar graph. Suppose this should be green percentage, blue, yellow, and then maroon. So but it should be mapped to 100%. This should be composite bar diagram. Okay, so the bar set should almost all equal to the 100%. Similarly, another kind of graph what we have is for the single attribute I have multiple values, multiple graphs, so what we call it as multi-graph. So like this, we're having different types of variations available for visual representation of data. And next one is that line graph. So is another way of presenting the data. So based on this, if I go into like points are available, so that should be point of lung cancer, and they should be the HIV/AIDS, and this should be maroon one, and this should be diabetes. So if I going to join this dots, the graph what we obtain should be the line graph. And similarly to how much HIV/AIDS, which should be the line graph. So most of these line graphs are going to be seen some many of the application like it matches and census, crickets, scores, and census. So most of the people are going to show this type of line graphs and all. And another type of charts what we have here is pie chart. So it should be a 360-degree graphical representation. So in terms of proportions, if I want to represent it, then it should be represented as a pie charts. So compares it should be subclasses and subcategories of a whole class or category using with different colored or patterned segments, right? So these are the some of the different ways of representing the pie charts. So initially I have to take a circle. From this I have to, it should be of 360-degree circle I have to take, so that's why it should be of 360 graph rotation. And this thing is going to be divided into different proportions. So 5 and then 10, let it be 25, 39, 6, 40, and then 23 like this. So the proportions are going to be represented. So then it should be pie chart, right? So like this, we're having different types of diagrams we're having for representing it, and for visualization also, right? So in this video I covered the what is the basic overview of data management and presentation. So the data management should be the data is going to be collected into formats such as values and measurements, and the data can also be represented in the form of numbers, words, or measurements and observations of different things. And different types of data I discussed. That one is that the data should be of numerical one or it may be categorical one. So the numerical one should be treated as the quantitative data, and the categorical data should be treated as the qualitative data. And again, this numerical data should be divided into different types like discrete and continuous one. So again, the qualitative and quantitative, if I take it as, then it should be descriptive should be the qualitative, and the numerical should be treated as a quantitative. So then the qualitative able to describe something, whereas the quantitative describe the numbers here. So the qualitative and quantitative. So all the time, just now what I said. So it should be measured one, but it should be data will be measured one should be treated as the quantitative. So the data what we observe should be treated as the qualitative. So these are the some of the examples what I explained here. And again, this quantitative should be of different types like a discrete and continuous. So the discrete value can able to take certain values only, whereas the continuous data can take with the value within the range. So by seeing this picture also, I can able to what kind of data I'm getting here. So if I'm going to write this as the brown or black on, it should have long hairs and a lot of energy like this. So this is the descriptive one, so it should become under the qualitative one. Similarly, from the same picture, if I'm going to represent the form of numerical values like 4 lakhs, it is 2 brothers and 400 pounds like this, then it should be consider it as a quantitative. So some of the types of also data available like spatial one and definite one. So the spatial thing is that normally presented maps of plans and provides the indication where the things are, where that the definite data is going to be drawn from drawings. And the methods what are available for this data collection should be of abstractive and unabstractive. So abstractive is nothing but show the data what we collected through interviews, surveys, focus groups, and observation, like this, right? And similarly, unabstractive means where we can able to collect the data through information from various values. And some of the data collection tools will be prospectory methods, records and secondary data, observations and surveys and review focus groups like this. And the data representation, we are having different types of data representation like tables, graphs, and then charts. So the table what can able to represent in the form of rows and columns. And similarly, we can able to represent the graphs into different like bar graph, like line graph like this. And charts should also be pie chart or bar chart, what we call it as different notations is there for representing that. And similarly, the table is the simplest way to summarize the data and when able to present it in different values and numbers and percentages. And which can what the data I collected it should be in the form of text one. So that thing should I can able to put in the form of table so that the others can able to easily understood this. And charts and graphs. So these are the another way of representing, visualizing the data. So normally we have different types of graphs. So normally, what we gather the data maybe in the form of text. Then from the text to the tables, I'm doing. So from the tables to graphs. So these are the conditions. We can not directly express the text to the graph directly. Okay. So we what the text what I'm getting from multiple sources definitely how to represent in the form of the tables one. From the tables only you can able to extract the graphs here, right? So this is the data what I gathered now. So from this table I have to going to construct this so that even the uneducated people can also be understood what the data it is, what the graph it is showing, what is representing here. So that thing can able you can easily understood. Again, this bar graph should be of different types. Like you should be what I'm showing should be column graph or vertical graph. Vertical bar graph it is normally, and same thing I can also be represent for the multiple bar graph. So multiple bar graph means for a single attribute I can able to represent all the values, all the graphs. So similarly for calculate answer how it will be. So it should be treated as a multiple bar graph. And similarly, I can have another kind of graph like what we call it as a line graph. So this line graph should be like where they can able to join the lines with the line dots with the line should be treated as the line graph here. So based on this data what I can have different types of options here, but what kind of graph is the suitable for visualizing the data you have to decide and you have to present it. So that is the thing we have to be no. So since we have different types of representations, which is the best thing? So similarly, if I'm going to represent it in a different 360 graphical notation, then how to go for the pie charts. So this thing we have to be divided into different slices of pie chart. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.